In 2005, Intel had the chance to buy Nvidia. They passed. Today, Nvidia is worth more than $3 trillion. Intel is worth less than 100 billion. That is not a typo. To understand how that happens, you have to understand what Intel was, not what it became. What it was. Founded in 1968 by Gordon Moore and Robert Noyce, two names that belong on the Mount Rushmore of technology, Intel essentially invented the modern microprocessor. The 4004, released in 1971, put a computer on a single chip. The world has not been the same since. By the 1990s, Intel was not just a chip company. It was the chip company. The Wintel duopoly, Windows software, Intel hardware, ran the personal computing revolution. Their processors were inside roughly 80% of the world's PCs at peak dominance. In 2000, Intel's market cap touched $500 billion, making it one of the most valuable companies on Earth. Their manufacturing was the best in the world. Their engineers were the best in the world. Their margins were the envy of every boardroom in Silicon Valley. They had every advantage, which, as it turns out, can be its own kind of trap. The first crack appeared quietly in 1999. Nvidia released the GeForce 256, marketing it as the world's first GPU, a graphics processing unit. It was designed to handle the parallel mathematical calculations required to render video game graphics. Intel noticed, and Intel was not impressed. Intel's business was CPUs, central processing units, sequential processing, one instruction at a time, executed with extraordinary precision and speed. GPUs did something different. They ran thousands of smaller calculations simultaneously. It was a fundamentally different architecture, and to Intel's leadership, it solved a fundamentally unimportant problem: games. They were not entirely wrong. At the time, GPUs were for games. The mistake was assuming they would stay that way. Between 2002 and 2006, Nvidia's engineers, led by Jensen Huang, were quietly building something that would matter far beyond gaming. CUDA, Compute Unified Device Architecture, was a programming platform that allowed developers to use GPU hardware for general-purpose computing, scientific simulations, financial modeling, and eventually something called deep learning. Intel had the opportunity to acquire Nvidia in 2005 for an estimated $20 billion. Intel's then CEO Craig Barrett reportedly considered it and walked away. The price, he felt, was too high. Nvidia's 2024 revenue was $60 billion in a single year. The board approved passing on the deal. Of course they did. Then came 2006 and a phone call that deserves its own documentary. Steve Jobs approached Intel CEO Paul Otellini with a proposal: make the chips for the first iPhone. Otellini ran the numbers. The margins were too thin. The volume was uncertain. He passed. The iPhone sold 217 million units in its first 5 years. The mobile chip market that grew around it was worth hundreds of billions. Intel was not in it. ARM-based processors were, and the engineers who learned to build efficient, low-power chips for mobile would later build efficient, powerful chips for AI inference. Otellini later told The Atlantic that the iPhone decision was the biggest mistake of his tenure. He was named Intel's CEO of the Year by multiple industry publications during his time in office. Remember that. By 2012, something seismic happened in an academic basement in Toronto. A neural network called AlexNet, built by Geoffrey Hinton's team, won the ImageNet competition by a margin that made competitors question whether the results were a mistake. It was not a mistake. It was a demonstration that deep learning worked, and that it ran on Nvidia GPUs. The AI research community took note. Within 2 years, virtually every major deep learning lab was training their models on Nvidia hardware. Intel's response was to invest in improving their CPU line. Their market research said enterprise customers wanted faster CPUs. Their enterprise customers, it turned out, were about to want something else entirely. This is the turning point. Not one decision. a pattern of them, each individually defensible, collectively catastrophic. In 2015, Intel acquired Altera, a programmable chip company, for $16.7 billion. The logic was sound. FPGAs, field programmable gate arrays, could potentially compete with GPUs for AI workloads. The execution was slow. By the time Intel had integrated Altera's technology into a coherent AI product line, Nvidia had lapped them twice. Then came the manufacturing crisis. Intel's signature advantage had always been that it designed and built its own chips. In-house fabrication, the most advanced nodes in the world, until it wasn't. Intel's 10-nanometer process node, promised for 2016, shipped in volume in 2019, 3 years late. During those 3 years, Taiwan's semiconductor manufacturing company, TSMC, raced ahead. By 2020, TSMC was producing chips at 5 nanometers. Intel was still catching up to 10. The company that built its identity on manufacturing supremacy had lost manufacturing supremacy. Nvidia, which had always fabbed its chips externally through TSMC, benefited directly from Intel's stumble. Their latest GPU architecture ran on TSMC's most advanced nodes. Intel's competitors were getting access to Intel-grade manufacturing. Intel was not. In 2019, Intel tried again. They acquired Habana Labs, an Israeli AI chip startup, for $2 billion. The gaudy chip line that came out of that acquisition was genuinely competitive on paper. On paper. In practice, the software ecosystem around Gaudi was thin. The developer tools lagged behind CUDA by nearly a decade of maturity, and enterprise customers who had spent years building NVIDIA-compatible infrastructure were not eager to rebuild it for a chip that might work. In technology, the hardware is half the product. The ecosystem is the other half. NVIDIA understood this in 2006. Intel learned it in 2023. There is a 17-year gap in that sentence, and it cost them everything. The numbers tell the story with brutal efficiency. In 2020, Intel's market cap was roughly $250 billion. Nvidia's was around $300 billion, similar scale, different trajectory. By mid-2024, Nvidia crossed $3 trillion. Intel fell below $100 billion. At one point in 2024, Intel's market cap was smaller than the quarterly revenue Nvidia reported. In August 2024, Intel announced it was cutting 15,000 jobs, roughly 15% of its global workforce. It suspended its dividend for the first time in 32 years. CEO Pat Gelsinger, who had returned to the company in 2021 with a bold turnaround plan called IDM2, was out by December. The turnaround had not turned. The AI accelerator market that Intel missed is projected to exceed $300 billion annually by 2030. Nvidia currently holds an estimated 70 to 80% of that market. AMD holds most of the remainder. Intel's share is a rounding error. So what is the lesson? It is not that Intel was stupid. The people running Intel were not stupid. They were optimizing for a world they understood extremely well, a world that was ending. The lesson is this: dominant companies do not fail because they make bad decisions in bad times. They fail because they make reasonable decisions in the context of their current business model, and that model quietly becomes the wrong one. Intel protected its CPU margins when it should have cannibalized them. It guarded its manufacturing identity when it should have questioned it. It evaluated Nvidia by what GPUs were, not what they could become. Being right about the present is not the same as being ready for the future. Intel was very, very right about the present. For a very long time. If you want to know how a different chip company saw the AI wave coming and rode it to $3 trillion, the story of Nvidia's Jensen Huang is next. Subscribe for more hidden empires.